Number 2, welcome to lesson 1.5. We're going to be solving equations and inequalities by graphing. Today, our essential question is, hey, how can you solve an equation or inequality by graphing? I'm sure you're surprised by that one. So let's go ahead and get right into this thing. We're going to start right away by doing an example. We're going to use a graph to solve an equation. And we're going to be using our handheld graphing calculators today quite a bit. We do have this Desmos calculator here on our Savas Realize with our interactive text, right? And I'm going to use that as well a little bit. But if you have your TI 83, 84, whatever graphing calculator you have handy, get that out. I'm actually going to be showing you how to use the TI 84 today. So if you have one of those, you can follow along with your TI 84, or you always have your Desmos calculator right here. So we'll do it both ways for you, so you can get some use out of that calculator. So let's go ahead and use a graph to solve an equation. So how would we do that? So the first thing that we need to do, if we're going to do such a thing, is we've got to take this equation that we're trying to solve. And of course, right, you could subtract 5 from both sides, right? And then, or maybe subtract 20 from both sides to be quicker, divide both sides by -3. You would get your answer, right? But we're going to show you a different method. So we're going to start by graphing. In order to do that, I've got to break this up into 2 different equations. So the one that's on the left side, I'm going to turn into one equation that we could graph. And then the one that's on the right side, right, is going to be simply y equals 5. We are going to go ahead and graph those 2 things. I'm going to use some graphing technology in order to do that. And then we're going to find the intersection. So let's go ahead and use our Texas Instruments calculator. This is a TI 84 plus emulator. All right, so in order to get to this screen, you're going to hit the y equals button. Y equals. That's what gets us where I am right now. Let's go ahead and put in the 2 functions that I'm going to be graphing. Y equals -3x. You can follow along and see that the buttons that I am pressing are shown in red on the keypad to the left. So we'll put in the plus 20 that's in there. And then next we're going to graph y equals 5. And there they are. My zoom is a little weird on this. Let's fix that. So let's go ahead and zoom. I'm going to go with, I would like it to be our standard zoom. I think that's going to be nice. Excellent, excellent. And so now we just need to find where those 2 lines are intersecting. The intersection of the 2 lines is going to be the equation, or sorry, the solution to the equation. You can kind of, see that these 2 intersect at 5. And it turns out that the solution to this equation is this, right? It's the x equals 5. And the idea is that at x equals 5 right here, that's the only point where these 2 functions, these 2 graphs are equal. We'll go back to our page and just go ahead and write our solution that x is equal to 5. Let's look at another one. All right, how would we solve this one? Well, let's do it by graphing. So again, I'm going to separate it into these two quantities. So I'll have y equals the absolute value of the quantity x minus 4. And then we have y equals 1/2 x plus 1. We're going to graph both of these, find the intersection. The intersection is going to be the solution. I'm going to do this one on the Desmos calculator, just in case you don't have your TI 83 or 84 calculator handy. And I'll just click in one of these fields, and I will write, now instead of the absolute value symbol, we're going to put in ABS parentheses. We'll put what's supposed to be inside of our absolute value, x minus 4. And then I'll go ahead and go down and graph 1/2 by saying 1 divided by 2. Scoot that over. X plus 1. Excellent. Well, there we have a graph. We might want to actually just kind of drag this over. It looks like this has two solutions, because remember, the solution is where the two graphs intersect. So that means that I have a solution at x equals 2, and I have a solution at x equals 10. Fantastic. So those are our answers. X equals 2 and x equals 10. You could plug them back into the original equation and verify that they're actually solutions. We're not going to do it because I know we're right. All right, moving right on. So they're going to have us use the graph. We've already done this. We'll move on. So moving on, the next thing that we're going to do is we're going to use a graph to solve an inequality now. And I think it's really helpful to kind of say what this thing is saying. It's saying what values of x is this quantity x squared minus 4 greater than 0? All right, so let's look at the graph of x squared minus 4, and we can determine what values of x are going to make this thing true, right? What values of x are going to give us a value that's greater than 0? In other words, if we were going to substitute some numbers in for x, how would that work? So let's go ahead and graph this. And I'm going to go ahead and use our Desmos calculator to do that. So we had x squared minus 4. Now, this would not be difficult for you to graph. You're used to these things. This is the graph of the parent function, y equals x squared, and it's going to be translated down 4 units. All right, and we're going to see that when we put the graph in. Let's go ahead. So there we go. Now, let's go back to what this question was asking. It's saying, for what values will we get a positive number, right? We're being asked this, right? X squared minus 4 greater than 0. We're saying, what values of x would you plug in that would make this expression true? And we could solve it, or we could look at what's going on here, right? It's almost like we have a cutoff right here. Everything below that dotted line is negative, but everything above that dotted line is positive. So, and it looks like that's happening, that change is occurring, right? From it being negative to the function being positive is occurring at -2 and at 2. So what we're saying is that any value of x, right, that's less than -2, or that is greater than +2, is going to be positive. So we could write that in a couple different ways. We could say that it's going to be positive on the intervals, actually, since we have two. And we're going to say from negative infinity all the way up to -2, right? And we're going to have a parenthesis there, not a bracket, because it's not positive at -2, it's 0. And then all the way from +2 up to infinity. In other words, right, this x squared minus 4 is going to be positive for any x greater than 2 and for any x that is less than -2. So these would be our two solutions. Well, excellent. Let's get rid of these things. Oh, come on. Oh, there we go. Got it. Oh my goodness. I must have my pen sitting on my desk. Why? There we go. All right, let's move on to the next example here. We now have to model a situation using some inequalities, and then we're going to find the solution to the inequalities by graphing. So here we go. We got a motorcycle, and it's 40 miles ahead of a car, but the motorcycle is maybe going faster. No, it's not. Motorcycle is traveling about 40 miles per hour. The car is traveling about 60 miles per hour. So eventually the car is going to catch that motorcycle and be ahead of it. So let's go ahead and model this situation with a couple inequalities. So first of all, I just want to kind of think about how what the situation is doing, right? Before we can just get right into making this inequality, and then graphing it. We got to think what's going on, right? What's our variable going to be in here? We got to make some sort of an inequality, which is like an equation, which is going to need to have a variable. So wouldn't it be safe to say that for our moto, we could model the distance traveled by 40x, where x is the hours that have passed. X is hours. And it looks like we could probably model the car with 60x, right? And that makes sense. If you're going 60 miles per hour in 2 hours, you went 120 miles, right? If you're going 40 miles per hour, in the case of the motorcycle, if you've been traveling for 2 hours, you go 80 miles. So that seems to make sense. So let's set up our inequality then, right? So we're wondering when is, right, if we plug in some x, it gives us a distance. When is this distance going to be greater than this distance? But there is a twist, right? Because this is what the inequality would look like if they started from the same place. But the motorcycle is 40 miles ahead, right? So we're saying, this, if I input some x, it tells me how far the car has gone. For this, if I input some x here, it's going to tell me how far the motorcycle has gone, except for that, we have to assume or take into account that the motorcycle has already traveled 40 miles. So there's our inequality that we have to solve. Let's go ahead and solve it by graphing. So what I'm going to have to do is graph the equation y equals 60x And separately, I'll graph the equation y equals 40x plus 40. So let's get out our calculators and do that. I'm going to do this one. Actually, I'm going to do this one on the Desmo. So I was going to get out the Inspire calculator. I think we might get out the Desmos. Just because of the units on this, it's going to be much easier to see on our Desmos calculator than it would be on our TI Inspire calculator. Or sorry, our TI 84. So we've got out our Desmos calculator. Let's go ahead and input these values. 60x. And then we've got our 40x plus 40. So this is why I chose the Desmos calculator, because we're going to have to zoom way out on this thing. And maybe. And there we go. The Desmos calculator is going to point out our point of intersection at which it just lost. What happened? There we go. Nope. Okay, so I had to do some stuff to get a better view of this. I went to my settings, and what we can do is go ahead and change your x-axis to be from -10 to 10 in your settings. And you're going to get a much nicer looking picture of this, and you'll be able to see this intersection here at the point 2, 120. So what does that point signify? That is the point where the car passes the motorcycle. So essentially, for any x that is greater than 2, the car has now traveled farther than the motorcycle. So let's write that, right? So what we've got is that for any x that is greater than 2, the car has gone further than the motorcycle. All right. Let's get another example in. So here we are. We're going to go ahead and try it. We've got the calculator right here. So I just want to show you what you need to do. We're going to graph. We're going to split this up into 2 pieces. This one, whoop, and that one. So essentially, we're going to graph y equals x squared plus 6x plus 5. And we're going to graph y equals 0. So x squared plus 5. There it is. And then this one, I'm going to have to write y equals 0. And there we have it. And it looks like we have 2 solutions here. We can actually point to them. I'm sorry, my bad. 2 solutions here. Now we want to find the intersection of these 2. Oh, these are the intersections. I apologize. So I'm sorry, I'm going to click this one. So remember, what this graph is telling us, or what this inequality is telling us, is that we're wondering what values of x make this true. What values of x make this greater than or equal to 0? We will find that those values of x are here. So then what that means is that this inequality is true for any x that is less than or equal to -5, right? Because we have a less than or equal to, that's fine. It's going to be equal to 0 at -5. And it's going to be true for any x that is greater than or equal to -1. And we can see that from these coordinates here. Okay, so we're going to go right into example number 4. We're going to use graphing technology. So in our previous examples, we had some really nice answers. We didn't wind up with any sort of decimals or anything weird, which is really not the way real life works. So what we need to do in most cases is use a function on our graphing calculator in order to tell us where the intersections are if we're going to be solving by graphing. So let's go ahead and get that done. It's the same process is going to hold true. I'm just going to show you one more little trick, and we're going to do that on our handheld calculator. I'm going to not use the decimals for it. We're going to have to do a little more analysis. So we're going to graph these two different equations, functions, and find their intersection. We're going to use a command on our handheld graphing calculator in order to do that. So the calculator that I like the most for this is this one. And we're going to use a cool function. So in order to graph, we're going to go to y equals. I'm going to go ahead and clear out what we did in our first example, and then put in our negative. Remember to use this negative down here on the bottom. You'll see it's highlighted in red. It's very important. If you use the other minus sign, it will tell you that there's a syntax. So it does not like it. So x squared plus 8x minus 13. And then we need the absolute value. So in order to get absolute value on this calculator, I'm going to have to hit math. We're going to go to number, and we have, there it is, abs, ABS. So we'll have absolute value. If you have the updated operating system, if you have a brand new calculator, the brand new operating system, it'll give you your it'll give you the absolute value. It doesn't say ABS. It looks a lot better. So -4. And let's go ahead and hit graph. Let's see what we see. Okay, looks like it intersects this graph in two places, right? We've got an absolute value graph. We've got a quadratic. We've got a parabola, right, facing or opening down. But if you'll notice that these 2 points, I could maybe estimate what they are, but I'm probably not going to get it very right. So what I'm going to do is rely on the technology to tell me where those two intersections are. And this is how we're going to do it. We're going to hit second and then trace. And that's going to get us to our calculate function, okay? And what we're looking for is an intersection. So I'll hit enter. It wants to know, well, what two things are you asking me for? And so first curve, we're just going to say it's going to, so the first curve was the parabola, and the second curve, we're going to just verify that it's the absolute value. And now it wants to know, well, where are you looking for? So if I point it over here, it's going to find this intersection. If I point it over here, it's going to find this intersection. Let's go ahead and go with the one with the lower x value. And it tells me that this intersection is happening at approximately 2.697. And the y coordinate is 1.30. 3 approximately. What we're really interested in though is that x coordinate. So we'll get into that a little bit. Let's go ahead and get the other intersection. We're not going to do that. So we got to go back to second calc. We're going to go back to intersect. Just tell it, okay, it's smart. It knows what curves we're talking about. And we're going to say, this is what we think it is. And it found it for us. Has an x coordinate of 5.303 and a y coordinate of 1.303 approximately. All right, so now that we have those values, let's go back and look at the answer to this problem. All right, what are the solutions? So the solutions that we're interested in are our x values. You want to know what x values make these two things the same. And it turns out that there are two possible x values that do that. We found that one that was on the lower side that had an x value of 2.697. And then we found the other one that had that was a little higher that had an x value of 5.303. Oh, it said round to the 10th. I went ahead and went to the 1000th because that's what NASA does. All right, so there we have it. I am going to strongly encourage you to go ahead and give this a try. Go ahead and try to use your TI-84 calculator. And that concludes the lesson, everyone. So we have solved equations and inequalities by graphing. How do we do that? We would break them up into two different equations that we're going to graph, and then we would find the intersection of those two graphs. Also, keep in mind that all of your practice problems are good over here on your last page here. So we're assigning things from these. Go ahead and have a look. You can also open the PDF if you need to. That's a fun tool to use. I save the PDFs of these just because it gives me something to look at. Sometimes I want to print out a piece of paper. Anyhow, thank you so much, Algebra 2, for watching. Go ahead and get some practice using your graphing calculators. I think it's a great tool to use. If you need any help, let me know. I hope that you are having a fantastic day. And if you're not, I hope it gets better. Take care.